Welcome. My name is Guy Royce. I'm a developer advocate here at Redis Labs, and we're going to be doing a cool Q&A session on RedisAI. I've spent the last month taking a look at RedisAI, and so I think it's pretty cool. And I'm excited to hear what these people who are way smarter than I am on this topic have to say about it. And so I'd like to welcome Pieter Cailliau, Filipe Oliveira, and Luca Antida. So welcome to the chat. So this is going to be a Q&A thing. I've got a couple questions to sort of level set, but we're also going to be taking questions from chat. So if you're watching and you have the chat thing going up and you have a question, just type /question and then your question, and I will see it. And if I deem it worthy, then I will pass it on, which means I'll pass it on. So let's start out with maybe quick introductions from the three of you, and then some questions.
Okay, who starts?
You can start, Filipe. You can start.
Okay, I'm Filipe. I'm work at Redis Labs. I'm a performance engineer, and I work on the development of RedisAI with Luca and with all other guys and Peter, Guy.
So I'm Pieter Cailliau. I'm the product manager for the modules that we develop at Redis Labs. RedisAI is one of them, but we have actually developed RedisAI in collaboration with Tensorwerks. And that should be a smooth segue to Luca.
Yeah, thank you, Peter. I'm Luca Antida. I'm CEO of Tensorwerks. It's a small company where we're developing RedisAI and other AI development products like Hangar, which is a data versioning tool.
Excellent. So so quick level setting question. I know, Luca, you did a talk, and I think several of you've all done talks for RedisConf this year. But I watched yours this morning, Luca. But I imagine there's probably some people that are here. They have questions, but they haven't seen that talk yet. So I kind of want to level set. So what the heck is RedisAI, and where did this idea come from? Why should I care?
Right. So RedisAI is really a high-performance model serving solution, where models are developed in TensorFlow, PyTorch, and even other machine learning frameworks like scikit-learn. You can export models to run on something like RedisAI, which kind of unites the concept of a key value store, of a database that is used to store data, and particularly data types like tensors, multidimensional arrays, and then being able to perform computations on those tensors to transform them into other tensors, like an image going from an image to a probability of that image to be a cat or dog or so on. And being able to do these two things, computation and serving data, persisting data in the same tool it's actually pretty powerful, because it allows you to compose your computations and to build architectures that are really scalable and efficient in the way they treat data.
Okay.
So
yeah, go ahead.
Yeah. So an introduction to RedisAI. So we effectively add three data structures to Redis. So I think we should also say that RedisAI is a module, and I've mentioned it before. So Redis modules add the ability to add data structures or also computing power. And effectively, RedisAI does both. I think Luca captured that. But in concept of data structures, we effectively add three data structures. So there are tensors, those were already mentioned by Luca, but also models. So you can set your models from the backend, or you can run them at least agnostic from the backend. And then also scripts. But I think we'll touch upon those later on, maybe in the questions.
And Filipe, do you have anything you'd like to add?
No, only to say that basically this model follows the standard way of developing a model in Redis. So basically we are not reinventing the wheel and leveraging what already is there on Redis. So basically we have a lot of things that's already coupled when you build something on the Redis infrastructure. So basically you build things that are based on something that's really fast. You have the part of connection handling. You have the part of everything related to not related to AI, but related to what I need to leverage AI serving in production is already taken care of, and we were able to focus on the addition of AI on top of Redis. So basically, tensors, models, scripts, and all of the part of connection handling, doing management of clients, etc. Everything was taken care of, and we just did things in the optimized way for AI, basically.
So while we're on it, guys, sorry for stealing your. I thought
that's fine. This is good.
So the way I sometimes like to simplify this is obviously a simplification, right? So, but you kind of like just write your data structures and your commands against those data structures, and then you host them in Redis, and you get all the goodies that are in Redis, right? So you get the fact that you can cluster it. You can have the high availability, but you can also have the durability options, such as RDB files and AOF options, kind of like all for free. My screen is not wide enough to do the quotes. So for free is obviously not really true. But it comes with implementing certain APIs, right? So maybe the best introduction I think that that I thought about that we could give is actually ask Luca how this module came to life, right? Because it started off, I think, with some tweets. Because Salvatore, effectively, the first module that Salvatore created was Neural Redis.
Yeah, exactly. So that was a time where I put my hands on TensorFlow that was released a few months earlier. So it dates back a couple of years or so, or even more than that, 3 years. And I've always been a fan of Redis, and I thought that it would be a great idea to have the two things in one object. And blocking comments were being developed at that time. So I tweeted, I sent a few tweets asking directions to Salvatore, and we interacted for a while. And that remained kind of a hobby project in my GitHub until 1.5 years later, when I got in touch with Redis Labs and Guy, and this whole adventure restarted again. I hadn't maintained that project that much, but and it's great to see this happening for real. So then, of course, the Redis Lab team came in and was fundamental, of course, to take that idea into something that could withstand the use cases that we target. So great.
Yes. So we on the other hand, in parallel. Hey, sorry, Guy. I will apologize later for interrupting you.
All over the place, Peter. Pace yourself.
Sorry. So in parallel, effectively, there was another module, and for those who might remember, there was a Redis ML, which was then focusing purely on machine learning models, on serving machine learning models, and then we thought like to combine and to merge these efforts. So there was a kind of like a bit more of deep learning effort that was being done by Luca, and we had some machine learning. We kind of like bundled it into a RedisAI. So that's just some history. Yeah.
Excellent. And just to be clear, when Luca said Guy, he didn't mean me. He meant Guy Korland, right?
Yeah, exactly. That's
so there's some questions in the chat here. A couple of them are sort of along a theme, and so I'm going to sort of average them out. But they were good. It's like, what would my architecture look like? Ahmed asks, what would my architecture look like for running RedisAI with TensorFlow Lite on IoT devices at the edge? And Masa says, what's the impact of RedisAI in the microservice configuration? And I feel like these are sort of the same question, because it's the, hey, where all can I run RedisAI? Right. Would someone want to take that question?
Right. Well, I can give direct experience on IoT devices, because this is something we do at the Tensorwerks parent company, which is Orobix. It's a company doing AI engineering, and we've been doing that for a number of years now. And one thing we do is we run on Jetson TX2s. So it's nice because those devices become, well, there are two configurations. One is that the device, for example, if it's a vision problem, takes input frames directly from a camera. Maybe they have a PoE Ethernet, a power over Ethernet interface that you can plug an industrial camera to, and you stream data directly into Redis, and it's kind of a self-contained solution, because then Redis will run on the GPU of that machine, run the computations on there. But it's more common for us to have a cluster of machines. One of them is doing the acquisition, and there's one that has a GPU on it. It's basically a physical microservice talking TCP with the Redis protocol, and you don't have to know anything about that. You just deploy a model there, and then just asking queries to that. Just run this model, get me the tensor. Run this model, get tensors. And there can be many devices acquiring data at the same time, and all the requests can go to that device that is equipped with the GPU. So that is I think it's a very effective way to run these kind of edge clusters, because it's more common to just have a few machines equipped with a GPU, and then some other devices streaming data to it. And from a microservice perspective, I think, as you were saying, it's a very similar situation, except that there you can use high availability, for example.
Yeah. And
you can do that yourself by spinning up more than one RedisAI, or using master replica or cluster configurations. And with a recent addition, something that Filipe worked on very hard is a DAG run, so a combination of commands that can also be commands that you run in a read-only mode. So basically, you can even target read-only replicas with the request of running a model, and that becomes also effective. And then, of course, there is enterprise, and maybe Peter can talk about that. So you can really cover the whole spectrum from very small to very large with exactly the same code and the same kind of semantics. I think it's quite convenient.
Can I add just something to that, to what Luca was saying regarding the part of microservices? Something that I find also really cool about AI is that taking an example of someone developing a microservice and already having the infrastructure around serving. For example, I have a Python microservice that relies on TensorFlow as a backend. It is really easy to couple your microservice with RedisAI and experience the boost of performance. Basically, you can leverage several microservices connected to one single RedisAI instance and get the best out of both worlds without your clients, without the clients doing the requests to your microservices noticing. You don't have to do anything. To the outside world, everything will be the same. To your microservice, you just, instead of relying solely on TensorFlow and running your inferences by yourself, you rely on model servers that's really optimized. So basically, you boost performance in a transparent way to the ones that are relying on your application. So I think that's really cool. Being able to do the transition, you will be able to boost the performance of your application without your customers noticing something bad, or without our customers having to change anything regarding how they connect to your application or how they contact it.
Okay. Can I add one more thing? So this is so for the microservices, one of the things is that I mentioned it before, but when you set a model into RedisAI, you obviously have to say, well, the backend is TensorFlow or the backend is PyTorch. But when you run it, you just specify the inputs and the outputs tensors that you have to that you want to supply. And as such, you could define a contract in between your developers and the people that are developing your model. You could say, well, my model wants to take these input tensors as input and needs to get these format of the output tensors, right? And then it's up to the data scientists to effectively decide whether that's best in a TensorFlow model and then in a PyTorch model and some Onyx runtime model effectively. So they can effectively, you can decouple that. And I think that is also a powerful thing in the world of microservices.
I have to be honest, actually, when I started digging into RedisAI, that was the feature that struck me as the most significant, is that it's that layer of abstraction. I have a software development background, so I'm always looking for abstractions. So, but that was one of the things that really stood out to me. So, yeah, thanks for calling that out. So we're kind of talking about how this, how RedisAI can be done on small things and big things and everywhere in between. And so there's a sort of a natural question that Dan has asked. It's a good follow-on. Is can we crank it all the way up to 11? Can RedisAI be run on geo-distributed active-active?
So good question. Right now in our active-active solution, we rely only upon the data structures that have an active-active implementation. We'll have to look into if we can implement a tensor, for example, as an active-active data structure, as a CRDT. If that is possible, however, I'm not the expert. Those are these guys. But in theory, it might be possible. But at this moment in time, we don't have a working solution for that.
Okay. Yeah, that's a perfect question for Guy Korland.
Yes, who isn't there? Yeah, but I do think that well, there are other scaling options, and I think Luca can talk more about them, or he already mentioned them. He mentioned, for example, the DAG run with the read-only option, for example. We can obviously scale it into replica offs or into slave replications of your data sets.
So we got another question here. Well, there's two questions. One I kind of want to answer, but it's from Kyle. And he says, how many guys work at Redis Labs?
Trick question.
I'm going to answer it really quick because it's kind of funny. There are 7 of us, which is super freaky weird. So, there you go. Harish asks, are there any Java client libraries, APIs that provide support for RedisAI? So what kind of client libraries do we have?
Can I?
Yeah, Filipe, go ahead. Yeah.
So basically, we have a Java client. So yes, we support partially the commands of RedisAI on Java. It's a constant evolution, and we have a Java client, a Go client, and an AI client. Further clients are in the process of being worked on, but basically, the most up-to-date is normally RedisAI in the Python version, mainly because it has a lot of contributors and a lot of requirements. And as you can see on other models as well, the Python client is always up-to-date, always up-to-date. It has a lot of community traction. Then we have the Go client, and that we have used for our benchmarks. So you can count on it for providing you performance boost and good numbers. So also it's we needed it to be updated and to be up to date, and we needed it to be highly performant. So yes, it's a very good client. And then we have the Java client that's got minor release still done today. So basically, in terms of order of development, of order of maturity of the clients, it's Python, Go, and then Java. But yes, Java exists, and it's on Java client exists, and it's being constantly updated.
But I'd like to add that any Redis client can work with RedisAI already. So it's just a bit more machinery, a low-level machinery. It won't be transparently transforming like an image or whatever into a tensor, where you'll have to provide the data type, the shape of the tensor, and the binary blob. And that's usually all that is needed. So it's, of course, very convenient to use, for example, for Python, being able to just provide a NumPy array and get a NumPy array out of a key. But it's usually replaces like 3 lines of code compared to the regular client, Redis client. So any language you can use Redis from, and there are many of them, you can use RedisAI, basically. And all the tests are written using the standard client, not the RedisAI Py, for example.
I do have an addition to this. Again,
no doubt.
You can be the judge if it's a useful addition. So we also have Redis Insight, and we plan to add support for RedisAI inside Redis Insight. So you'll have the ability, for example, to choose your model from your desktop application, Redis Insight, and upload it or deploy it into RedisAI. And then also you can run it, given that you specify certain keys, certain input tensors and output tensors. And they're still considering some cases when, for example, when the tensor represents an image, you could just visualize, for example, the image. So that is upcoming and soon to come work inside Redis Insight. I'm excited about.
Yeah, that'll be cool. I actually, Luca, you were saying the thing about any client library can access this thing, and I think that's another key thing that's really kind of powerful about RedisAI is that it becomes language agnostic. Then, if I really want to, if I have a Node.js application, I can do that. I can do it from Elixir. I can do it from Ruby. I can do it from Java. I can do it from anywhere. And so I think that's very powerful.
Regarding this, just a small addition, sometimes you have to pre-process and post-process your tensors in order to feed them to a model. And you can do that within RedisAI using script, which is a Python-like script, which is a language provided by the PyTorch runtime that looks like Python. It's actually statically typed, so it's maturing over time, but it's already exposing all the Torch API. It doesn't run in Python. It looks like Python, but it runs natively within the PyTorch runtime on the GPU if you so want. So this is a very important piece because, for example, if you run a YOLO, one of those models that identify objects around images, then you have to post-process the output of that bounding boxes. It's not like it outputs a tensor from which you derive bounding boxes that you need to display. But if you have to re-implement that stuff on the client side, then it becomes complex. But if you deploy that as a script, then you also can do these operations without necessarily having them on the client. So at this point, it becomes even more language independent because you don't even need to care about that. You just need you just get the coordinates of the bounding boxes the way you would display them in any language.
So we got. I think we need to wrap this up in about 3 minutes. So I think I'll end with. Well, there was one good question, and then I got two questions I want to ask. So we'll do a little quick. Mansa asks, are there any limitations for the data volume that can be served by RedisAI's models, or by a model that's in RedisAI? I think I know the answer to that, but I'd like to hear what you think, or what you have to say.
The biggest model we served and will publish in Zoo is one of the Hugging Face natural language processing models. It's about 1.3 gigabytes of model. Like it has billions of parameters because it has to model languages. And so we had to overcome the limitation of Redis strings being 500 megabytes by chunking the protocol, the blobs that we were sending in. But once it's in, there's no limitation.
So maybe, Zoo, I don't know if he need a brief introduction to that.
Yeah, so Zoo is a repository that will start populating in a few days, weeks. We put all the popular models in there with scripts that will get you going in like 2 commands, and you can actually inspect those Python scripts that will be used to download the model and export it and prepare it for RedisAI and deploy. Because it's usually quite easy to do, but if you haven't seen it once, then it takes a while to wrap your head around. So you'll have models for vision, you'll have models for texts, and so on. And we think it will be a great way to get started, to have something that you can maybe fine-tune and redeploy, or take as a model for your own models.
I would like to add just one thing regarding the part of the dimensions, not only of the models, but also of the data. So sitting on top, RedisAI sits on top of Redis as any other model. So basically, the way we scale is exactly the same as other model scales. So when the limitation starts, we have 2 potential limitations. So the computational power and the dimension of the data. So in either way, you can also always scale either horizontally and vertically. within the Redis way of doing things. So basically, you can start breaking data into smaller chunks of data, or start breaking data so that it fits a machine, and when it doesn't fit that specific machine, you can scale in the exact same format. And regarding scalability, we have one cool thing about RedisAI and the decoupling of the backends himself is that we can control the level of parallelism within each shard or within each portion of data, so that you can basically scale in the same manner on one machine or 10 machines. Ideally, you scale horizontally and vertically in the exact same manner. So the dimension of the data or the dimension of your computational power for providing the response to a model should not be a limitation, and you should always be able to scale. That's the overall answer for that.
Hey guys, so I need to drop, but I'm just going to avoid your light question since my answers on Star Trek and Star Wars are not relevant anyway. So
I wasn't going to ask that actually.
All right. Bye. Thank you.
Yeah, so I think we're probably good. Luca, Filipe, do you guys want to plug your talks real quick, and then we can wrap this up?
So basically, what I wanted to say is that any deep details or any deep intricacies that you guys didn't saw answered here, you can always reach out to us either via GitHub or within the conference or any other of the ways of contacting us. We are more than glad to share our thoughts around how to measure things, how we develop things, everything. We are really happy to see that people are starting to engage with the RedisAI model. So please do share your thoughts about it.
Excellent.
Yep. I hope RedisAI will be used in ways that we don't foresee. So, it's composable. It's, it follows kind of the Redis philosophy of having comments that you can mix and match. So I'm really looking forward to see what the community builds with it.
That is exciting, isn't it? It's always cool to see people do stuff with, use your stuff in ways that you didn't anticipate. It's always very exciting.
That's the best feeling.
So, okay, well, thank you both very much. And thank you, Peter, even though you've selfishly left us. Enjoy the rest of the conference, and you guys have a good afternoon.
Yeah, thank you, guys. Much appreciated.
And thanks everyone for tuning in.